Solving equations, distributing. Sometimes when solving equations, there's a term, often just a number, outside of and right next to parentheses. When this happens, it means that we are multiplying the term outside of the parentheses by everything inside. This is called distributing. Which means to spread out evenly. So distributing means to spread out evenly. So let's look at example 1 up here in the right corner. We have 3, and then we read this, 3 times the quantity 2x plus 5. That's the way we read that. 3 times the quantity 2x plus 5, because everything inside the parentheses is treated as one thing. We're multiplying 3 times everything in there. So if we have to multiply 3 by everything inside, I usually use these little arches like that to show I'm multiplying 3 times 2x. And the result to that is 6x. I'm going to use a different color here. 3 times positive 5 is 15. And so that is the result of multiplying 3 times the quantity 2x plus 5. Be careful to only multiply the term right next to the parentheses by the things inside. Note that in example 2, the sign is also part of the term that is distributed. So let's look at example 2 and see what I'm referring to there. So here, the sign here is distributed along with the 2. So a negative 2 is what is distributed. So we have the 4 right here. And then we have the negative 2 that is distributed to negative 3x. Well, negative 2 times negative 3x is positive 6x. And then we multiply that negative 2 by positive 7. And that's going to be minus 14. And so this is the result. It's also a good idea usually to combine like terms. We can combine those that 4 and that negative 14, and we get a 6x minus 10. All right. Now, sometimes there are more than 2 terms inside the parentheses. This doesn't change the process at all. Example 3 is a situation like this. So we multiply that negative 4 by 2. Ooh, there's something new. 2x squared. Don't let it bother you. Negative 4 times 2x squared is negative 8x squared. Doesn't change anything. Negative 4, I'm going to draw that a little lower, times a negative 3x. Well, a negative times a negative is a positive 12x. And then we have the negative 4 times the positive 7, which is negative 28. That's example 3. All right. Sometimes it is difficult to know what term should be distributed. It's hard to know. And I think example 2 above is kind of like that. If we look at example 2, we don't distribute that 4 because it's not right next to the parentheses. But example 4 is another way in which it's difficult to know what to distribute. So let's look at that. So what is being distributed here? Well, there's no number right next to the parentheses. Well, there isn't one written there, but there really is a sneaky one. Whenever there's no number, it's really just a 1 there. So just like if we have x, that's really a 1x. Similarly, in this situation, when there's no number right in front of the parentheses, it's just a 1. So we have that 5 outside of parentheses right here, and that's going to come down. And then we distribute the -1 to the 7x, and that's going to be a minus 7x. And then we distribute the -1 to the -2, and that's going to be positive 2. And now we can combine the 5 and the 2. So we have the -7x plus 7. And you may ask, why didn't I write 7 minus 7x? Well, it's just standard kind of mathematicians decided that we would write any x terms before constants. So that's why I do that. All right. One method for working with distribution is known as the area model of multiplication. This consists of a rectangular diagram where the terms blank of the rectangle, the terms outside of the rectangle, represent the length and width of the rectangle. And the terms inside represent the area, that's why we call this an area model, of the sections of the rectangle. So the total area of the rectangle is the sum of the sections and the result of the distribution. So let's have a look at this. So the way that we do this is we set up a rectangle, and we have our 7, I'm going to highlight right here, and then we have our -2x plus 6 right there. So my 7 I'm going to put right here, and then I'm going to have -2x and 6. So that's a positive 6 because I didn't put a negative on it. So this is the height or the width, and this can be the length. So now I do 7 times -2x will give me a, let's see, I'll do purple since I have blue and red there. That's going to be a -14x. And then, so -14x is the area of this part of the rectangle. And now I do 7 times 6, because length times width is area, and that's going to be 42. So the result of my original distribution problem here is -14x plus 42. So I just take this right here, add them together, and that's the result. Now you may be wondering, why would I do this? I understand how to do distribution just fine. All right, great. We're going to be using this area model later, and so I want to introduce it right now. So here on the distribution in the rectangle, we do not include the 9 because it's not part of the area model here, only what is being multiplied. So we have the -3, be careful to include that sign, and the quantity 5x minus 4. So we have -3, 5x. Did I say plus? I'm not sure. I might have. I meant minus 4. All right. So -3 times 5x, that is going to be a -15x. -3 times -4, that's going to be a +12. We have to be careful to include the 9 here in our result. So we have 9, and then we have -15x plus 12. So our 9 came right there, and then this -15x plus 12 is right here. We should combine those like terms, the 9 and the 12. So the result will be -15x plus 21. And that is solving equations with distribution. We didn't solve any equations with it, but we will later.